trigonometry, talking about triangles. Let's talk about some triangles. Here's a triangle. Here's one. There's another one. Let's talk about the angles that make up a triangle. There's one angle. There's another one. There's another one. Here, the angle is larger than 90 degrees, and we call this obtuse. Here, the angle is less than 90 degrees. We call this acute, an acute angle. Here, the angle, the angle equals 90 degrees, and we call this a right angle triangle. Right angle triangle. This is what we want. It's signified by this square. You see these ones are round, signifies an angle other than 90 degrees. They're curved. This one shows that this angle here is 90 degrees. These are the triangles that we want to play with. Why? Because you can take any one of these triangles and make it into two right angle triangles. See that? There's another one right here too. And you can take this angle and cut it in half. There's a right angle triangle, and there's another one. 1, 2. 1, 2. So if you just learn the rules for this triangle, you can take any triangle, break it down, and solve for it. What are the rules for a right angle triangle? This angle is not 90 degrees, that's why it has a curve here, and we signify it with theta. The rules are sine of theta is equal to sin is opposite over hypotenuse. Okay? We'll call this opposite because it's opposite of the angle. If the angle was up here, if we signified the angle would be here, then this would be opposite. But we signified the angle here, so this is opposite. We're always talking about this angle. See, I could call this one phi, but I don't want to confuse the picture. And then we would be saying that sine of phi is a over c. It's the opposite. This one we're going to call the adjacent. Adjacent to theta, and this one will be called the hypotenuse. And this one always is called the hypotenuse. Because it is the longest one. Cosine of theta is not the opposite, it's going to be the adjacent. A over b, and then tangent of theta, you should remember it as sine theta over cosine theta, which is equal to b over c divided by a over, this one should be c. And then this one will equal b over c, bring this up, flip it, it's going to be b over a. Oh, b over a. Okay, there we go. Some people memorize this thing here as SOHCAHTOA, and that's cool, where this is opposite over hypotenuse, this is adjacent over hypotenuse, and then this is SOHCAHTOA, SOHCAHTOA. So sine opposite adjacent, SOHCA, there. Cosine adjacent hypotenuse, tangent opposite, adjacent. SOHCAHTOA. So you could remember it like that. I remember it that sine and cosine are always over hypotenuse. How do you know the difference between them? Well, sin, you don't want to be opposite of sin, so that's how you remember that. And tangent is going to remember sine of the cosine. There's one last thing you have to remember here, and it's the Pythagoras theorem. A squared plus b squared is equal to c squared. Okay? And that's just for the lengths. Has nothing to do with the angles, just for the lengths of the sides. Everything else has to do with angles. So these are the rules for the right angle triangle. That's what we need to remember.